In this highlight video, we're going to talk about naming ethers, alcohols, and thiols. So after you watch this video, you should be able to write IUPAC names for these three functional groups given a structure, and be able to turn this around and draw a structure if you're given a name. Let's start with ethers. In ethers especially, we'll have, or you'll run into sometimes, what are called common names, and these are usually used for just simple structures. The way this naming goes is that you name the alkyl groups attached to the oxygen, and you name it listing those alkyl groups in alphabetical order, followed by the word ether. So alkyl, alkyl, ether. Let's try this down below. So notice we have an oxygen here as an ether, we have an ethyl group on the left, ethyl group on the right, and so we can combine those and we can call this diethyl ether. 2 words. It's a very common solvent. The next one, we can see that we'll have an alkyl group here and an alkyl group here. So the one on the left is a, what is that? That is a sec-butyl. And this is a propyl. So we would, remember, alphabetize the sec-butyl. With the butyl there, we would just call this sec-butyl propyl ether. All right, but if we get a slightly more complex structure, this gets a little bit more difficult, right? So we're going to then go on to IUPAC naming. And remember, this is going to be what we want to be able to do for exams. This just builds on what we've done before. We're going to name the longest carbon chain, or ring. And we're going to then name the oxygen-bearing substituent as an alkyl, but then we're going to drop the YL and add oxy. So for example, if we have OCH3, then the alkyl group there is methyl, but we're going to drop that YL and we're going to go to methoxy. All right. If it was 2, it would be ethoxy, 3, propoxy, and so on. After we've named that substituent, then we're going to just name the molecule like we name an alkane. These what we call alkoxy substituents are treated just like alkyl groups or halogens. There's no priority one over the other. So let's go back and name these 3 compounds using this IUPAC method. So in the first one, we have to pick the longest chain. So of course there's 2 ethyl groups, so we'll just pick one of those, and this would be, the parent would be ethane. And then the other part of it, including the oxygen, would be ethyl and oxyethoxy. So this would be ethoxyethane. Because there's only 2 carbons in ethane, it doesn't matter which carbon we attach the ethoxy group to, right? We'd always count it from that end. And so we don't even need any numbers for this one. All right, so what about the second one? The longest chain is going to be right here, is a butane. Right, and then our substituent is going to be here, propyl propoxy. And this is at the 2 position. So 2-propoxy butane. All right, what about the last one? Okay, we see that our parent is going to be the ring, a cyclopentane, right? And we're going to have a methoxy group here, and we have 2 methyl groups over here. So where would we start our numbering? We could have a 1, one of them is going to be a 1, the other one a 3. We're going to put number 1 over here because that puts the first two substituents at 1, 2, 3. And so this one is going to be, so methoxy comes before methyl. This gives us 3 methoxy, 1 dimethyl cyclopentane. Alcohols are a higher priority functional group, and so we're going to name them using a suffix rather than just a prefix. So when we name alcohols, we will name the longest parent, just like usual, but we're going to make sure that it includes the alcohol. All right? Even if the alcohol is part of a shorter chain, we're going to use that shorter chain to be the parent. We're then going to drop the E from the alkane name and add OL, which is going to mean alcohol, right? OL right here. We then number the chain to give the alcohol the lowest possible number. It takes priority, and then the rest of the naming follows just like we've done before. So let's just start simple. So here we have an ethane, right? So this is just drop the E, add OL. This is just ethanol. Here we have a propane. Let's do it stepwise. We're going to drop the E. We're going to add OL, but what we also need to do, because this is at the second position of propane, we do it like this. We go propane, and we stick the number in between the parent and the OL, so 2-ol. We used to put the numbering out in front, but now this is the preferred way. Let's look at the last example. So in this one, we're going to start with a pentane. We're going to number that pentane to put the alcohol at the lowest possible number. So we'll start numbering from right and go to left. 1, 2, 3, 4. So we have a 4-methyl pentane 2-ol. Let's do a few more complicated examples. Let's look at that first one. What is the longest parent that includes the alcohol? So even though the longest chain could go all the way out to the right, the longest one that has the alcohol included is going to be this one right here. We're going to number this to give the alcohol the lowest possible number. So we'll have 1, 2, 3, 4, 5, 6, 7. We have 2 substituents. We have a methoxy group and a 3-carbon piece over here, right? A propyl. And our parent is 7 carbons long with the alcohol at position 2. So we're going to start with methoxy. 6 methoxy. 3 propyl. Heptane. 2-ol. All right, getting pretty long there. So now we've got a ring. So when we have alcohols in rings, the alcohol is always going to be at position 1 because it's taking priority. So we have 2 possibilities of numbering this ring then. We could go clockwise, which would put the chlorine at 3, or we could go counterclockwise, putting the methyl group at 3. Because chlorine comes earlier in the alphabet, we'll give it the lower number. 1, 2, 3, 4. So this is going to be a cyclopentanol. Because the OH is automatically at position 1, we don't have to put that 1 in the name. So this name is going to be, we'll start way over here, 3-chloro, 4-methyl cyclopentanol. The bottom two have multiple alcohols. And so if there's 2 alcohols, we call it a diol. If there's 3, we call it a triol. To name the diol, we just put diol at the end of the alkane name. So this would be an ethane. Ethane, we keep the E now, and 1,2-diol. All right, this is also called, as a common name, ethylene glycol. All right, the triol would be a propane, and it would be propane 1, 2, 3, because there's 3, triol. And this has another name, is glycerol, and glycerol is very important in biochemistry. Maybe you've heard of triglycerides. Those are common fats, and they are linked up with the glycerol molecule as the center part of that structure. Let's turn this process around and draw a structure given the name. So on these 2 problems, what we're going to do is draw the structure, think about the name and whether it's correct. If it's not correct, we're going to give a correct name. All right, so like always, we look at the ending here, the parent hexanol. And so we're just going to draw the cyclohexane. Oops, I left that off. Cyclohexanol. Now notice out here we have some chirality for the different substituents. So cyclohexanol, so it's going to be 1s goes to the position of the alcohol. We also have an ethoxy group at 3. So we have an OH, let's say this is 1, and an ethoxy group. And this is at 3. So we want to have 1s, 3s. So I think sometimes the easiest way to do this is just to choose one chirality arbitrarily and determine what it is. If we come out correct, then we keep it. If it's wrong, if it's backwards, then we switch it. All right. So the easiest way to do it really is to put the substituents coming forward, because that way we can put the number 4 group going back. So I'm going to arbitrarily do that for both of these substituents. And now I have to figure out whether those stereogenic centers are R or S. So let's look at the alcohol first. So of course the alcohol is going to be the highest priority. The second highest priority is going to be on the ring going towards the ether. So this would be number 2, number 3 would be over here, and of course the hydrogen is number 4. So we're going this way. This is counterclockwise. Number 4 is back. This is S. S is what we want. We lucked out. We got that one right. What about the other side? So the ether, this oxygen would be number 1. Number 2 would be over here going toward the alcohol. 3 would be down here. And of course, lowly hydrogen is number 4. And this is going this way. This would be R. But what we want is S. And so to get the correct answer, we need to switch that one. Okay, remember, we're going to keep the alcohol like it was because we lucked out and got that one right. We want to switch the ethoxy group, so we're going to put it back. All right, and now this should be S, and this should be S. So one thing to avoid, if you draw the structure like the one I did on the left, and you say, oh, this is R, don't say, oh, I'm going to correct the name by changing this, or not that one, changing the other one to R. Okay? because I'm giving you the name, and so you have to change your structure to match the name. All right, so is this structure correct? So this should be at 3. This is at 1. Everything looks good, so this is actually correct. All right, let's try the next one. Heptane 5-ol. So 2, 3, 4, 5, 6, 7. Let's count the alcohol. 1, 2, 3, 4, 5. I'm going to put the alcohol right here. We have a methoxy group at 2. And we have a methyl group at 3. All right, so is that correct? No, this one is incorrect. What's wrong with it? What's wrong with it is that the alcohol needs to get the lowest number. And so we need to number this one from right to left, so the alcohol is at 3 rather than at 5, even if these other groups get higher numbers. All right, so the correct name is going to, they're still in the same order though, right? 6-methoxy 5-methyl heptane 3-ol. The last two functional groups we're going to look at here are sulfur analogs of the alcohol. So a thiol is a sulfur, like a sulfur alcohol. And a sulfide is also sometimes called a thioether, and that gives you its related functional group. All right, so when we name thiols, we're going to name them just by adding thiol as a suffix onto the alkane name. We're leaving or keeping the E for the alkane. We're going to give these priority over any of the groups we have so far. And so our parent would be like this, and we would number it to give that thiol the lowest possible number. So we have a heptane, and we have a methyl group at position 6. 6-methyl heptane 3-thiol. All right, in the second one we have a ring. We'll give the thiol number 1. It ranks higher than the ether. 1, 2, 3. And so this one would be, let's write it up here, 3-methoxy cyclohexane thiol. Because that thiol is automatically at position 1, we don't need to use the number. All right, for sulfides, the only way we're going to really look at is we're going to name them as common names were named for ethers. But we'll just put sulfide at the ending. And so this has, we look at two alkyl groups. We have a propyl. We have an isopropyl. So we're just going to list these in alphabetical order and then say sulfide. So we put isopropyl first, isopropyl, and then propyl, sulfide.